Hello and welcome to Density. Hello and welcome to Mr. Simon Explains Density. So what do we mean by the word density? Density is simply the amount of stuff in a bit of space. That's it. That is the one idea of density expressed in one sentence. Obviously, we wouldn't write that on an exam. So let's look at it in a bit more detail. Firstly, what does it actually mean? Well, the amount of stuff in a bit of space is basically just the mass in a given volume. So here we've got some atoms in some space. They're quite spread out, so we might say they're quite low density. Let's compare this to another diagram. Here we have more atoms in the same space, so it's more dense, less dense, more dense. One more example. Here we've got even more atoms in the same amount of space, so it's the most dense of all the three. So have a look at these three pictures. Which is the most dense? Which is the least dense? Pause the video now and think to yourself. So obviously the one on the left-hand side is the most dense because it has the most amount of stuff in the same space, the most mass in the same volume. You might think that the middle one is the least dense and the right one is in between. Or you might think it's the other way around, but actually, let's count it up. Let's count up the number of particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So actually they have the same amount of stuff in the same amount of space, which means they actually have the same density. So this one has the most, these two actually have the same density. Now, obviously, if we looked at only the top half of this box, there's nothing in there, so it's not dense at all. If we looked at the bottom half, it's very dense, but overall, it has the same amount of mass in the same amount of space as the middle diagram. So let's see if we can put this into words in a more formal way. So density, as we said, is the amount of stuff in a bit of space. We wouldn't write that on an exam. We could write density is the amount of mass in a volume, because that's what we're saying. Amount of stuff is just the amount of mass, bit of space is a volume. We can do better than that, a bit more formal data. Density is mass per volume. Per just means in a volume or for every volume. So these three things mean exactly the same things. We're just sounding a bit more intelligent, a bit more clever each time. Now, mass is kilograms and volume is meters cubed. So we wouldn't write this on an exam, but density is kilogram per meter cubed. And that will become important when we look at the formula. Now, actually, you don't really need this formula for any exam or almost any exam question. I'll show you a little way you can kind of cheat. But this is the actual formula for density. And it comes from this. Density is mass per volume. Or really, it comes from this, the amount of stuff in a bit of space. The amount of stuff is mass, the bit of space is volume. So mass in space. Density is mass per unit volume. Now, you'll often see this for density. Something's density is 1.6 kilograms per meter cubed. What does this mean? It means there's 1.6 kilograms for every meter cubed. If you had 1 meter cubed of the substance, you would have 1.6 kilograms. 1.6 kilograms for every meter cubed. Another example, 3,800 grams per centimeter cubed. This means that for every centimeter cubed, you have 3,800 grams. It's still mass in a volume, therefore it's still density. It's just sometimes we use grams and centimeters cubed because maybe we're working with quite small things. So let's look at some questions without ever having to use the formulas. This is a very similar or very typical exam question. A tree has a mass of 12,000 kilograms. The volume of the tree is 12 meters cubed. Calculate the density of the iceberg. So obviously, if you know the formula, great. You can plug in the numbers, you can get your answer, great. But maybe you're struggling, maybe you've forgotten the exam question, forgotten the formula. How can we solve this? Well, actually, we can kind of cheat using the answer line. Look, it will always give you this. Density is blank kilograms per meter cubed. It's actually told you that density is mass per volume. Density is mass over volume. So how much mass is there for each bit of volume? Well, let's break this down really, really simple. There are 12,000 kilograms for 12 meters cubed. That's literally what it has in the question. Mass of this volume of this. So now we need to work out how much mass is in 1 meter cubed. So we could, do this kind of thing. We can say, well, actually in 6 meters cubed, half of it, there must be half the mass, which is 6,000 kilograms. In 3 meters cubed, which is half of it, we'd have to half the mass as 3,000 kilograms. And then you can obviously see how we're going to get to 1 meter cubed, and we end up with a density of 1,000 kilograms in 1 meter cubed, which means our answer is 1,000 kilograms per meter cubed. We haven't used a formula. We used some very simple reasoning, some very simple maths, and we've got the answer. So now we're going to look at two similar questions where, again, you don't really need to use the formula. So a bottle of liquid has a mass of 500 grams. The volume of the water is 125 centimeters cubed. Calculate the density of the bottle. So you can pause the video now and try this question. So again, you do not need to use the formula because they've given you the formula, and we can also work this out just using our common sense. So even though they might have thrown you off by not using kilograms and meters cubed, doesn't matter. It's still mass per volume. It's still the same. So how much mass is there for each bit of volume? Well, 500 grams for 125 centimeters cubed. So we need to work out how much in 1 centimeter cubed. So there's a number of ways we can do this. I've just chosen to divide by 10 to start with to try and simplify it, to show you the process. I'm going to divide by 10 again and show you that there's 1.25 centimeters cubed and 5 grams. And then, it's easy now to see how we get to 1 centimeter cubed. We divide by 1.25. We end up with 4 grams in 1 centimeters cubed, which means the answer is 4 grams per centimeter cubed. That is the density. What about if they turn it around? What about if they say, what is the mass of the rock? We've given you a density and we've given you a volume. What is the mass of the rock? Do we need to use a formula? Do we need to know how to rearrange? Well, if you do, great. But if you don't, we can still use common sense and reasoning to work this out. So if you don't know how to rearrange, how are we going to do this? Well, density is mass per volume. It's the amount of mass in a bit of space. In 1 meter cubed, there is 6,000 kilograms. That comes from the density. 6,000 kilograms per meter cubed means exactly this. So how much in 0.3 meters cubed? Well, in 0.1 meters cubed, there is 600 kilograms. In a tenth of this, there must be a tenth of this. Now, in 0.2 meters cubed, there is 1,200 kilograms, which is doubling both of these. And then if we scale it up again, oh look, we've got 0.3 meters cubed and we've got 1,800 kilograms, which means our mass in 0.3 meters cubed is 1,800 kilograms. Simple, no rearrangement, no formula. We've just used our reasoning and our one definition of this, density is mass per volume, to get the answer. Okay, final question. They might again rearrange and say, what's the volume? So it says the density of flour is 1.4 grams per centimeters cubed. A cook wants 5.6 grams for a recipe. What volume of flour do they need? So again, I don't know how to rearrange. How am I going to do this? Well, if you think and use your reasoning, we can work this out. You need to remember, the only thing you need to remember is density is mass per volume. So if we look at the actual density, it means for every centimeter cubed, there is 1.4 grams. That's what that means. So in 2.8 grams, there is 2 centimeters cubed. In 4.2 grams, that means there's 3 centimeters cubed. We're just simply scaling this up, which means eventually we get to 5.6 grams for 4 centimeters cubed. So that is the volume. Again, no rearrangement, no formula, just used our reasoning and one simple formula, definition. So 3 questions for you to try. Pause the video now and try these questions. So let's quickly show you the answers. Hopefully you either did those using the formula or you did them using your common sense and reasoning, and hopefully you found them quite easy. Now I've shown you a different method to solve these problems, so that will give you, quite a few marks in an exam each year. So a tiny bit of extra information that you need to be aware of. I will let you pause the video now. You can take notes on the first 2, and I will see you again in another video. Thank you and goodbye.